in order to factor this, first thing we might look for is a GCF. There is none. Next thing is we could multiply front and back, do the little x, but there's a shortcut to this one. Because what you notice is 9 is a square number, and so is 100. So if both edges are square numbers, there's a shortcut. So first we want to do is find out what squared each one is. So for the first one, that would be 3x times 3x is 9x squared. And for 100, that would be 10 times 10 is 100. So once we found those two pieces, now we do a little thing. What we do is we take each number inside, so the 3x, multiply it times the 10, and double it. And what do we get when we do that? Well, we get 60x. Now, if that number right here is equal to the middle, ignoring the negative, right here, ignoring the negative. So if this equals this, there's a shortcut. Now for this one, it doesn't equal, so it's not factorable. It kind of quickly, no, this is not factorable, we're done. But let's say it did equal, so let me rewrite the problem. What we would maybe have would be something like this, 9x squared minus 60x plus 100. So what I did is I changed this to negative 60x, which is that. So if this matches the middle, then it's a quick, easy factor. So what you do is you take each of these as the pieces of the factor, and you take the middle sign as what's in the middle, meaning, watch, I get 3x minus 10 times 3x minus 10. So that is factored form. Again, if this matches the middle, you just write this and this twice, with this for each piece, which you can also write that as 3x minus 10 squared. So that is a good answer, and actually this is a good answer. They're both the same. It's a shortcut. So when the edges are squareds, don't start working all hard at it and doing the other methods. Break it down. See if when you multiply them and double it, if it matches the middle. If it doesn't, you stop. But if it does, like say this is the problem, then you can jump to the answer fairly quickly. All right, in order to factor this is called a difference of squares. Do you notice that this is n squared and this is 11 squared? You also notice it's only two terms. Usually these are giveaways that you know there's something special here because it's only two terms. Everything else tends to have three terms. So there's no GCF. And I do notice these are squared. So once again, we break it down as what squared are the things? What are we having squared on both sides? So this is n squared, and the other one is 11 squared. So if you have a difference of two squares, your answer is going to be n plus 11 and n minus 11. What you'll notice is it's very similar to this one, except this one has both the same sign. This one has one positive and one negative. So my answer is just that. Now for this one, same thing goes. We can notice, okay, is this a difference of squares? Oh, those are two squareds. But there is a remember me talking, I like to have my x squareds positive, so I want to get rid of that negative. I just tend to not like that. So what I'm going to do is I'm going to pull out a negative 1, and that would give me a 49x squared minus 144. Now I did also switch these, because when I pull a negative out, won't that become a positive and that become a negative? And I usually like the squareds first, not in the back. So it just helps sometimes to rewrite it so the squareds first, and so the squared piece is not negative. You don't have to, it's just very, very common. Anywho, so I now want to factor this. And what you should notice now for these two pieces is it's a difference of squares again. What are my two squareds? Well, you should know for 49x squared would be 7x squared. And for 144, that would be 12. So what I now have is a negative in front, and it's a difference of squares. So I have 7x plus 12, and I have a 7x minus 12. Just don't forget the negative in front. You could put a negative or a negative 1. So if you want to put a negative 1, you could. Or just a negative, it's your call. But that would be factored form. All right, again, when you have a negative in front of an x squared, it's good usually to pull out a negative so you don't. And also rewriting it so the x squareds first is a common practice.